This is a brief discussion on hyperspectral sensing, which most people who work in remote sensing believe is the future of remote sensing. And what it really means is going from a discrete multi-channel model of remote sensing where we have several channels that are discrete points on the spectrum across the visible near-infrared and mid-infrared spectrum, all reflected. We go to a model where we have, in effect, a continuous sensing of the spectrum from the UV at about 0.3 micrometers or 300 nanometers out to around 2500 nanometers or 2.5 micrometers, producing anywhere from, depending on the spectral resolution, producing anywhere from dozens to hundreds of channels of discrete channels of data that are actually, they're not discrete, they're continuous across the spectrum. So this really is just a relatively brief discussion of this technology. And so in the model of hyperspectral sensing, you can think of an X and a Y, and then in the Z, or the spectral dimension of the remote sensing data cube, you have really hundreds of channels that, when layered in this fashion, this is an average data cube with 224 channels, but when layered in this fashion, give you a much greater data density across the entire spectrum, from the UV all the way out to the mid-infrared. And this is just an example again of a virus data cube that comes from the a virus or average, I'm not sure exactly how it's pronounced, sensor that is flown regularly on high-altitude aircraft out of California. This is a program, a NASA program, that is out there really for the development of this technology for a variety of purposes. So if you want to take a look at this, there are some links at the end of this where you can look at the virus website and learn a bit more about this form of hyperspectral sensing, which is more, I guess, public domain, you would call it. Now, in hyperspectral sensing, we do have some different resources available to us. One of them, probably the one that's most widely used in the public domain, is the Earth Observing 1 satellite that is used, actually was launched in 2001, and it carries a couple of sensors on it. And the one that's of particular interest to us here is the Hyperion. We've mentioned the ALI or ALI sensor on the EO1, which was the test bed for the technologies that are now incorporated into Landsat 8, the Landsat 8 Operational Land Imager, or OLI, also called ALI. A little bit confusing. But the one we're mostly interested in is the Hyperion, which is a hyperspectral scanner, relatively narrow swath width, about almost 8 kilometers wide. You can see how that compares to a typical TM scene, and also you can see how the ALI compares to a typical TM scene. Again, these were low-cost experimental sensors, relatively low cost, and so they do not have a real wide swath width. Their main purpose was to test some of these technologies so that we could determine how useful they're going to be and what we're going to be doing in the future. So again, there's a link at the end of the at the end of this to take a look at the EO1 satellite. And the EO1, had a lot of technologies on it, has a lot of technologies on it. It is still operating, and you can find that data from both the Ali sensor and the Hyperion sensor through the Earth Explorer, through the normal gateways that we use. So if you want to take a look at it, that's a good place to do it. And you can find, lots of scenes around there, various that you're familiar with, that you can work with, that have, the 220 channel swath of digital data that the Hyperion typically collects. And there are some very high quality scenes in there that I think are very interesting if you're a remote sensor and you want to learn some things about hyperspectral. And I do recommend that if you're intending to to go further in this and to work in this area, perhaps at any time in the future, because I really do think this is the future of of where we're heading. And maybe to give you a bit more of the sense of that future, I'm just highlighting some of the private sector uses. And again, this is an example of a private sector, a relatively typical private sector vendor. The most important thing here is the company that builds the sensor, Headwall Photonics, and they actually build a sensor called, I think it's the Headwall Recon. It's handheld sensor, and they build a number of different hyperspectral sensors. They do have a series called the micro hyperspec sensors, which range out to let's see, almost 370 channels in the range. Again, it's a variable range, but it typically ranges from the UV all the way out to about 2,500 nanometers or 2.5 micrometers. And they're relatively, they're relatively small. They're relatively light. These devices, the smallest of these devices, weighs about 1.5 pounds or 0.68 kilograms. So, there is, there really is just a great opportunity for development, I think, in the private sector using low-cost platforms like this quadcopter that's shown here for these kinds of sensors. And they do have lots of different kinds of applications. Again, this is right now, the sensors that are being produced by this company are mainly being marketed to the certainly to the public sector, but to military, homeland security markets in in government agencies principally, but also in private sector agencies as well. So, again, this is something to know. But these things are being used for some very interesting non-military applications, which I think have a lot of possibility. And this is the future that's coming, and it's really the future that's already here. There are a lot of drones flying in the private sector. The public airspace is currently about to be opened up in the next year or so to more and more drone UAV activity. So we better get ready for it, because it's going to come whether we like it or not. It's already here, as a matter of fact. So if you want to learn some more about these things, take a look at the links on this page, and there's a link to a hyperspectral imaging wiki, which is pretty useful. This is a link to something at USGS where they actually test different types of minerals and other kinds of land surfaces with very high resolution radiometers, and they produce spectral plots of these materials, which can be very useful if you are working with hyperspectral to determine what typical spectral plots might look like. And then a couple links here to Avaris and Hyperion. So hyperspectral, very cool.